Let's learn about some regenerative ideas. So the title of this presentation is From Maize Failure to Microbial Restoration, Regenerative Ideas for a Zambian Farmer. In addition, we had the opportunity to interview a farmer called Mr. James Banda. So here we have the farmer's context. Mr. Banda has been farming for over 20 years. He relies entirely on rainfall since there is no irrigation where he lives. Normally, the rainy season runs from November to April. He uses basic hand tools, a little bit of manure from his cattle, and when he can afford it, chemical fertilizer from the government subsidy program.
Challenges identified. So from my interview with the farmer, I picked two main challenges that he told me about. And the first one is unreliable rainfall. So with unreliable rainfall in this sub-region, there's late onset, early cessation, 2 to 3 weeks dry spells during crop growth with 30% yields loss. So as we can see, this is maize here. Due to low rainfall, we can see the soil is cracked, there's low yields, and there's like 2 to 3 weeks dry spells. Then the second problem that I identified was decline in soil fertility plus high input costs. So with the low rainfall, there is decline in soil fertility and the input costs are very high. The soil is hard and pale, fertilizer prices doubled, yield dropped from 4 to less than 2 tons per hectare. So this farmer used to have a lot of yield, right? But due to the challenges, his yields dropped from about 4 to less than 2 tons per hectare, which is very bad. And we can see the prices of fertilizers have like doubled, which is quite expensive for him to maintain. Why this matters? Why do these challenges matter? So firstly, challenges are not just like an inconvenience. There's consequences, real life consequences, right? So the first consequence would be food insecurity. We have things like maize is the primary food. Maize is like the staple food of Zambians, right? So if there's like low yields, everyone suffers. And there's food insecurity in the country, not only for the farmer, for everybody. Then there's debt cycle. He can't afford inputs, which means there'll be lower yields. And if there's lower yields, there's less income. If there's less income, he can't buy inputs, and it keeps recycling like that. Then vulnerability. More dry spells mean total crop failure risk. So the more dry spells, the more the crops fail to grow. Then there's soil degradation, loss of organic matter, poor holding capacity. Then, as we can see here, if there's high costs like expensive fertilizers, more pesticides and chemicals, high input costs, there's lower profit. And if we have low costs, which is like when we use compost manure, less pests, less chemicals, lower input costs, there's higher profits. So in this situation, we encourage low costs by using those products.
So my first case study is the APCNF from India. This is a practice of solid fermented manure and liquid microbial culture. It is practiced in Pradesh, India. So this practice has restored soil biology, reduced need for chemical fertilizers, improved soil moisture and retention. The results are that farmers have reduced costs by 50 to 80% and maintained yields during
Food Web School. So this case study is by Ellen Ingham, I think. Yes. And the practice is biologically complete compost plus compost extract. How it works. Compost extract applies the entire soil food web, which is the bacteria, the fungi, and the protozoa in minutes. Benefits. It increases water holding capacity, builds soil structure, and suppresses diseases. Then the key principle here is that there's going to be healthy soil, which equates to fungi dominant and crumb-like structure. So I also think this is going to be helpful for my farmer because it might solve most of his problems. Then practical ideas for Mr. Banda. What ideas do I have for this man? So the first idea is a small trail, right? He should designate a 10 by 10 meters maize plot. So I don't think he's supposed to change everything in one spot. He should start by a small trail. Apply local made Jivarutham, which is local cow dung, because this man is also a livestock farmer. local cow dung plus water plus ripe fruits or soil every 2 weeks. Then the second one is add crop residue, which is mulch, which is like maize stalks. You just add them on top of your crops to retain moisture. Then my second idea for him is low-tech compost extract. Bury a perforated bucket of compost in a drum of rainwater, stir, strain, and spray onto the trial plot leaves and soil. Like that. So the first one is small trial plot, and the second one is mulch to cover the soil. Then the reflection and the conclusion. What have I learned? I learned that farmers face compound problems, which is like climate and economy. It's not only about the climate, also the economy, right? Because as I mentioned earlier, my farmer uses subsidies to just like produce his chemical fertilizers and everything. So the government is involved in a way. And solutions must be local and low cost. This is a suggestion from me to the farmer. Then the realism. Mr. Banda cannot buy microbial inoculants, but he can brew Jivarutham with his own kettle. Then further needs a simple soil texture test, local training on compost quality assessment. And my final thought is that regenerative farming is not a return to the past. It is a biological upgrade for the future.